I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 30, we will discuss about cognitive radio in 5G. The cognitive radio (CR) technology adopts wireless communication to its environment. It senses and utilizes available spectrum, optimizing performance. And CR, that is cognitive radio, enables efficient spectrum usage, reduced interference, and improved quality. This innovative technology revolutionizes wireless communication for various applications. We'll discuss in detail in the future slides. Now, the first we'll see the definition. The IEEE defines cognitive radio (CR) as a communication system designed to be aware of its environment and its internal state. This awareness allows CR to make adaptive and real-time decisions to optimize radio operations effectively. Unlike the other radio technologies, CRs, that is cognitive radio's decisions, are based on environmental factors rather than on specific location data, which broadens its adaptability to different network contexts. And the main objective of this CR is the primary objective of cognitive radio is to improve spectrum utilization. In 5G networks, spectrum is a critical finite resource, and CR offers an innovative solution by dynamically adjusting to environmental changes to make efficient use of available spectrum even in heavy populated networks or limited bandwidth areas. This is the main objective of the cognitive radio CR, and why we are using this cognitive radio. This cognitive radio's importance lies in its ability to increase spectrum efficiency in 5G networks by dynamically organizing and adapting to conditions based on real-time environmental sensing. This adaptability enables cognitive radio to respond to changes in network demand and interference, ensuring optimal performance even as conditions shift. CR can self organize its functions, making it highly suitable for the fast paced, data intensive environments of 5G. Next, the key functions and the benefits of CR. Spectrum resource management. First we'll concentrate in this spectrum resource management. The spectrum resource management in cognitive radio involves efficiently managing and organizing spectrum holes or unused frequency bands to increase network capacity and maximize resource utilization. By identifying these gaps, cognitive radios enable the network to use underutilized frequencies effectively, reducing bottlenecks and improving the overall network capacity, which is especially critical in the high demand environment of 5G. And as far as the security management is considered, it is security management in cognitive radio networks (CRNs). Cognitive radio network (CRNs) addresses the unique security challenges arising from the heterogeneity of these networks. CRNs consist of different types of devices and network architectures which increase potential vulnerabilities. Robust security functions ensure that these diverse systems can operate securely within dynamic network environment, protecting data integrity and preventing unauthorized access. Next, mobility and connection management. This mobility and connection management allow cognitive radio system to support seamless network transition by identifying neighboring networks and detecting available internet access points. Cognitive radios can choose optimal routes for data transmission. This function also supports vertical handoffs, which are essential for maintaining continuous connectivity as devices move between different types of networks, making it ideal for mobile 5G applications. And coming into the benefits, the integration of cognitive radios in 5G network enhances spectrum efficiency, adaptability, and resilience. By making intelligent data driven decisions, cognitive radios optimize spectrum usage, adapt to change in real time, and ensure robust network performance. This combination makes 5G networks more versatile, capable of handling fluctuating demands, and resilient against interference or network disruptions. Next, CR device concept. Coming into the overview, the concept of the cognitive radio devices centers around creating a highly intelligent, high performance user terminals called CR terminal. This advanced device is built to dynamically adapt to its environment by leveraging cognitive radio properties and allowing for a seamless user experience. By integrating all necessary CR features within a single terminal, CR devices achieve exceptional spectrum management and adaptability. This integration enables the device to operate efficiently in real time by recognizing, analyzing, and responding to the surrounding network conditions. The CR terminal therefore stands as a smart solution for spectrum utilization in complex network environments, intelligently accessing available channels and ensuring smooth communication without interferences. This is the overall diagram of the CR devices. All functions are given: spectrum sensing, spectrum sharing, and spectrum handover, etc. The first one is the spectrum sensing and the CR devices. Spectrum sensing is a fundamental capacity of CR devices involving a systematic process that allow them to detect and classify signals in the surrounding environment. This process is divided into distinct steps to ensure effective spectrum usage. The first step is signal detection, focuses on identifying the presence of signal in a given channel without needing to understand the specific signal type. This step allows the CR device to efficiently find open spectrum spaces, helping prevent interference and manage resource effectively. Following deduction, the signal classification step enables the device to extract specific features of the detected signal to understand its type. By classifying the signal, the CR terminals can make informed decisions about how to use available spectrum, adopting its communication strategies based on the identified signal's characteristics. Together, these steps in spectrum sensing empower CR devices to optimize connectivity and maintain efficient, high performance network interference interactions even in dynamic environments. Next, channel availability decisions. And the channel in cognitive radio technology, channel availability detection is an important step for managing spectrum efficiently. The first task is free channel deduction, where CR devices identify available spectrum holes, that is, unused spectrum hole means unused frequency bands in the environment. Once these free channels are detected, the next step involves the spectrum allocation scheme, which allows CR devices to manage and share these channels effectively among users. The goal is to enhance spectrum utilization by dynamically allocating available channels, which helps minimizes interference and maximize the overall efficiency of the communication network. This adaptability makes CR technology highly effective, makes CR technology no, effective in the environment with varying levels of spectrum demand and congestion. Next is security, the challenges if you are considering. The cognitive radio technology introduces several security and pricing challenges. One of the main security concerns is the potential security threats posed by the dynamic nature of spectrum access. Since CR systems are flexible and can operate access various spectrum bands, this adaptability opens the door for vulnerabilities, including unauthorized access. To address this, robust authentication is authentication mechanisms are required to ensure that only authorized devices can access and communicate over the spectrum. One on the pricing side, the chosen channel allocation scheme plays a significant role in determining the cost of using spectrum. The pricing model can vary based on how channels are allocated and managed. Additionally, CR devices must be equipped with the available ability to negotiate channel prices dynamically, adjusting based on real-time availability and demand to ensure that pricing is both fair and efficient, ultimately optimize the use of spectrum resources. Next is spectrum handover. The spectrum handover is the process in which a secondary user changes its frequency dynamically, either when the primary user appears or when the transmission quickly degrades. In the cognitive radio system, secondary users are allowed to use spectrum that is not being used by the primary users. However, when a primary user starts transmitting or the quality of the secondary user's transmission drop, the secondary user must change its frequency to avoid interference or signal degradation. No? This process known as spectrum handover. It is critical for ensuring the secondary users that can maintain communication without disrupting primary user service. To achieve this, a well-designed handover scheme is required, which ensures smooth transitions between frequencies and minimizing disruptions in service. Next, environment adaptation. In a dynamic environment, a cognitive radio system may encounter various changes such as topological shifts, noise, or interference that can impact its ability to sense and use available spectrum. These changes may cause degradation in performance if not addressed effectively. For example, if the environment becomes more congested or interferences increases, the system's initial spectrum sensing and allocation may no longer be effective. To adapt to these environmental changes and maintain optimal performance, CR systems need to implement adaptation techniques. These techniques allow the system to adjust its strategies for spectrum sensing and transmission and reception in response to changing conditions, ensuring consistent and reliable communication in fluctuating environment. Next, CR routing. This cognitive radio routing is a process that ensures efficient communication across networks, CR network, cognitive radio networks, by enabling CR devices to interoperate with different systems. Since CR networks share spectrum with primary systems such as infrastructure-based mesh, ad hoc, or sensor network, CR routing is heavily influenced by the spectrum sharing techniques in use. The architecture of the network determines the type of routing algorithm needed. For example, in a mesh or ad hoc network, the routing algorithm must support dynamic spectrum access, no, and efficient pathfinding. Additionally, CR devices may function as relay nodes as forward data from CR devices to another, allowing network to maintain connectivity even in the absence of direct communication links. This routing algorithm for CR systems must be designed to accommodate these complex dynamic network conditions while ensuring efficient data transmission and spectrum utilization. Next, network structure, cognitive radio network. Just we'll see the overview of CRN. The CRN consists of two distinct networks, primary network and a secondary network. The primary network owns the licensed spectrum and includes the primary radio base station, which is responsible for controlling and managing the communication resources. It also comprises the primary use of hold, write, to use the spectrum. On the other hand, the secondary network shares the unused spectrum with the primary network, consisting of cognitive radio base stations and users and who do not hold exclusive rights to the spectrum but can dynamically access available channels when the primary users are not using them. This shared spectrum model allows more efficient use of the available radio frequencies. Next, the key capabilities of CR, cognitive radio capabilities. These three functions are very, very important functions. First one is the cognition. One of the primary feature of cognitive radio is its ability to understand its environment. CR can detect and interpret information about its geographical location and the operational conditions of the network. This awareness allows the CR to identify which frequencies are in use, which frequencies are free, enabling it to make decisions based on real-time spectrum availability and network requirements. Next, reconfiguration. Based on the cognitive knowledge it gathers, a CR has the ability to reconfigure its parameters dynamically. This means that depending on the situation, a CR can automatically adjust its transmission power, frequency band, and communication protocol to optimize its performance and avoid interference with the primary users and ensures efficient use of the spectrum. The ability to reconfigure is essential for adapting to changing network conditions and maintaining robust communication. Next one is the learning. Another critical capability of CR is its ability to learn from experience. Over time, cognitive radio system can analyze past interactions, outcomes, and network conditions to improve their performance. CRs can experiment with new configurations and strategies in different situations, allowing them to continually enhance their efficiency and adapt to evolving environment. This learning capability makes CRs highly versatile and responsive to dynamic wireless communication needs. Next, this cognitive radio facets. There are two types of cognitive radio facets are there: spectrum sensing and spectrum database. The spectrum sensing and the cognitive radio system, spectrum sensing is the process by which CR devices track and monitor local spectrum bands to identify which portions are being used by licensed user and which are available for use. The unused portions of the spectrum known as white spaces or spectrum holes can be dynamically created and removed as licensed user enter and leave frequency band. CR devices can take advantage of the unused portions without requiring licenses. Spectrum sensing can be performed in two ways, that is cooperative spectrum sensing, non-cooperative spectrum sensing. Cooperative spectrum sensing, multiple CRs, cognitive radios, share their spectrum data, helps each other detect spectrum holes more effectively and improving the accuracy of the sensing process. On the other hand, non-cooperative spectrum sensing, each CR device operates independently and makes its own decisions about spectrum availability based on its own local observations. Next is spectrum database. The spectrum database is another approach used in cognitive radio system to identify available spectrum. That is, TV stations and other licensed spectrums users provide information about their future spectrum usage, typically for upcoming weeks, to a database maintained by the Federal Communication Commissions, that AFCC. CR devices can access this database to find out which portions of the spectrum are free, thus avoiding the need for costly and time-consuming spectrum sensing. However, there is a key limitations to this approach. The database is not updated in real time, which means CR devices may miss out on newly available spectrum if the database does not reflect the recent changes in the spectrum usage. This can reduce the effectiveness of the spectrum across the CR devices. This is the main drawback of spectrum database. Next, combined approach. To overcome the limitations of both remote spectrum sensing and database access, a combined approach is often used in CR system. By integrating both methods, spectrum sensing and accessing a spectrum database, CR devices can quickly and accurately detect unused spectrum. This hybrid method allows for more efficient spectrum utilization, ensuring that devices can access available spectrum more reliably. As a result, this approach not only helps improve the QoS, that is quality of service, but also supports the increasing number of devices needing spectrum across in dynamic environment. This combined approach enables CR system to optimize spectral usage while maintaining high communication performances. And so that's all about the and the types of, if you are looking into the types of cognitive radio, this heterogeneous spectrum sharing, full cognitive CR, and spectrum sensing, and this is the benefit of the types of. So it operates a heterogeneous operation, runs in multiple RANs with the same different radio access technology. It uses network-centric approach with a fixed frequency band. Spectrum sharing, multiple RANs share the same frequency band and coordinate to unoccupied subbands optimally. And full cognitive CR takes into account all parameters and a wireless node can be aware of. Spectrum sensing, what it will do, focuses on detecting unused channels in the RF spectrum. So what is the benefit I have told you? Both types optimize radio sources and improved QoS. What do you mean by QoS? Quality of service, right? This is the both heterogeneous and spectrum sharing CR types optimize radio resources, improving the overall QoS, quality of service. Compared to traditional radio system, cognitive radio technologies enable more efficient spectrum use and enhanced communication performance, supporting the growing demand for wireless communication. Coming into the conclusion, cognitive radio enhances the spectrum utilization by enabling dynamic access to unused frequencies, and it uses the methods like spectrum sensing and spectrum sharing to improve network efficiency. CR employs spectrum sensing to detect free frequencies, spectrum sharing to enable multiple networks to use the same band efficiently, and both heterogeneous and spectrum sharing types optimize resource for better communication quality. And the CR technology ensures more efficient spectrum use and improved quality of service. So the CR technology, one more time I'll tell you, ensures more efficient spectrum use and improved quality of service. By dynamically managing spectrum access, CR enhances spectrum usage and delivers a better QoS, quality of service, for the users. So thank you. Hope everyone enjoyed learning about cognitive radio. CR technology optimizes spectrum use and improves communication efficiently. It helps in dynamic spectrum access, enhancing quality of service, that is QoS. Looking forward to meeting you again for more insightable discussions. Thank you once again for your attention and participation. Thank you.